Now we're looking at graphing circles, and I'll show you what to do with this type of problem. We really only need to know two things in order to graph the circle. The first thing we need is a center, and the second thing we need is the radius. So the center, remember, this is x minus h squared plus y minus k squared equals r squared here. For the center, you just take the opposite sign of what's here, because if it's negative here, these match up. That makes this a positive 4, and this is positive and that's negative. That means this is a negative 2. So it's the opposite sign, because this would be the same as y minus 4 here, and then this would be y minus a negative 2. For the radius, we know that r squared is equal to 36 because of what's given here. Therefore, if we take the square root of both sides, we end up with r is equal to 6. So graphing this, get a graph real quick. Hopefully I can do this. One, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. That should be enough. We've got 4, negative 2 here. There's our center. And then we're going to go up 6, so that's 2 and another 4 puts us here. We're going to go down 6, and I did that on purpose here. Here we've got 1, 2, 3, 4, 5, 6. So again, we go 6 here, and here we have 4 and another 2. Gives us a point here, and then just draw the best you can for a circle. See, and if you notice, my markings are off a little bit, so the circle looks off, but if you do it that good, that's good enough. So again, we rewrite the radius to find the center, or rewrite the equation to find the center and the radius. So we have that. That's x minus 4 and y minus a negative 2. That makes our center at 4, negative 2, and radius at 6. You can use a compass or you don't need to. You get something like this. Again, these are marked off by 2, so it's 2, 4, 6, 2, 4, 6, 2, 4, 6, and 2, 4, 6. Here's another problem. It says the epicenter for an earthquake is the point on the Earth's surface directly above the Earth's origin, or the earthquake's origin. A seismograph can be used to determine the distance to the epicenter of an earthquake. Seismographs are needed in 3 different places to locate the earthquake's epicenter. Use the seismograph readings and locations from A, B, and C to find the epicenter of an earthquake. So we've got these 3 readings here. Here's the center for each of these, and this would be the radius, because it's 7 miles away from this center. It's 4 miles away from this center, and it's 5 miles away from this center. So we would draw all 3 of these circles. I'm not going to draw it, but I'll show you what it looks like. So we would draw each of these circles and put it on a graph. Again, the centers and the radiuses, and we would just kind of guesstimate that where the 3 circles meet, where the intersection is for all 3, that would give us our epicenter. So our epicenter in this case would be about 2, 4, 5, 2. Okay, and you just kind of guesstimate that. And if you notice, the center here is negative 2, 2.5, and the radius is 7. For B, it's 4, 6, and the radius is 4. And for the C, it is 3, negative 2.5, and the radius is 5. So the next question is going to ask, why do we need 3? Well, if we had only done 2, then we would know, for example, if we'd done A and B, we would know that the epicenter is somewhere in here, and that's not very accurate. Similarly, if we did B and C, it would be somewhere in here, but that wouldn't be very accurate as well. So by doing 3, we actually get a point where all 3 meet up. And that point where A, B, and C, that they all have in common, gives us our epicenter. So it's about 5, 2. And again, why 3 seismographs? The reason is 2 circles intersect in 2 points. We wouldn't know which one was the epicenter, so we'd need the 3rd circle. Okay? And here's another one where we have to graph. I'm just going to give you the center and the radius. So the center here is the opposite of this and the opposite of this. So center is at 4, and then the opposite of this is -3. For the radius, r squared equals 16. So r is equal to the square root of 16, which is 4. Now what happens if this number is something kind of strange, like 7, for example? If this was 7, then we would do the same thing. We'd say r squared equals 7. We'd take the square root of both sides. We'd say r is equal to radical 7. And then we'd get our calculator out. And radical 7 is equal to about 2.6. So what you'd do when you'd graph it is you'd go up 2.6, down 2.6, left 2.6, and right 2.6, and then connect the dots. In this case, we're going up 4, down 4, left 4, right 4. So I'll show you what that looks like. So here it is. Here's our center at 4, -3, and we'd go up 4, down 4, left 4, and right 4, and then we'd connect those 4 dots. Here's another one. Center is the opposite of +8, so it would be -8, and the opposite of +5, which is -5. Our radius, we're lucky a 3rd time because that's a perfect square. We know r squared is equal to 121. Square rooting both sides, we'd get r equals 11. So we'd plot this point, and then we'd go up 11, down 11, left 11, and right 11, and connect the dots. And it would look something like that. So again, these are by 3, so this would be up 11, down 11, left 11, right 11, connect the 4 dots there. And we're done. Thanks.